A very good evening. We are students of BFC 20903 Mechanics of Materials from Section 6, Group 9. The title of our project presentation is Design, Fabricate and Testing Composite Materials Plates. First of all, I'd like to introduce myself and my group mates. My name is theebashini and I'm from Rajeswaran, CF 220211. Mohamed RaFiq bin Rozi, CF 220160. Saarvin anak lelaki sangkar, CF 220167. Risyaanth anak lelaki murugan, CF 220248. Dina sofea binti mohamed nadzri, CF 220194. And lastly, izzati binti AMINAKBAR, CF 220242. The presentation will be consist of introduction of the project, choice of materials, concept of composite plate theory, strength analysis, calculations, methods of fabrications, conclusion, and also drawing. Introduction to composite materials. Materials that are made from two or more constituent materials that have significantly different physical or chemical properties and are combined to produce a material with characteristics different from the individual components are also known as composite materials. There are three types of composite. First of all, metal metric composite. This consists of a dispersed ceramic, for example oxides and carbides, or metallic phase which consists of lead, tungsten, molybdenum, and a metallic matrix, for example aluminium, magnesium, iron, cobalt, and copper. Next, a ceramic matrix and embedded fibers of another ceramic material like dispersed phase make up ceramic matrix composites. Lastly, polymer matrix composites have embedded glass, carbon, steel, or Kevlar fibers in a thermoset epoxy, polyvinyl chloride, nylon matrix. Now let's take a look on the advantages and disadvantages of composite materials. First of all, advantages. Firstly, design flexibility, where with thermoset composites, designers can design nearly any shape or form they want. Secondly, improved productivity as a result of lower assembly costs achieved by combining multiple previously assembled parts into a single one by industrial designers and also engineers. Next, lower cost per cubic inch. When compared to conventional materials like wood, engineered thermoplastics, and metal thermoset composites have lower material costs. On the other hand, if you take a look at the disadvantages of composite material, one of them is that composites are more susceptible to damage because they are than more brittle than wrought metals. Um, then cast metals are also frequently brittle. For the following reasons, repair introduces new issues like materials have short shelf lives and require refrigeration for transportation and also storage. In many cases, hot curing is required but necessitates special equipment. It takes time to cure either hot or cold. Composite materials and its applications. Firstly, built bridges. Bridge decks, bridge enclosures, and entire structures can all be constructed from composites. Secondly, home enhancement. Most likely, this is the most prevalent use of composite materials in construction. Wood composite is an excellent choice for flooring in homes, especially for outdoor patio decking, courtyard cladding, and other applications. Besides, refurbishment is another use for composite materials. They can be used in reinforce existing structures like cooling towers, beams, floors, columns, chimneys, and others. Moreover, composites can be used to make architectural features like facades, cladding, domes, roofing, and structures like cupolas. Furthermore, modular structures, masts, towers, pipes, tanks, access covers, and water control structures all make use of composites in civil engineering and infrastructure. Additionally, they are frequently utilized in rail applications like platform systems, gantries, and trackbeds. Last but not least, composite materials are ideal for maritime applications like bulkheads, boat hulls, and numerous other components for commercial, recreational, and military boats and ships due to their corrosion resistant and excellent lightweight but strong properties.
Next, I will continue for the choice of material. In this project, we choose aluminum. Uh, in the left picture, there are sample of aluminum that we choose. Aluminum is a silvery white metal and also is the element theme in the project chart. It makes up more than 8% of mass of the Earth core, make it the most prevalent metal on the planet. The yield strength and aluminum element strength are two crucial elements when thinking about the mechanical qualities. And in a specific loading configuration, tension, compression, and etc., the yield strength specific, the highest strength required to elastic deform the part. So this is the table that summarizes of mechanical properties for 6061 aluminum alloy.
Continue this presentation. Before that, my name is Dina Sofea Nadzri. My metric number is CF220194. So I will continue with concept of composite plate fabricated in classical laminate plate theory. So material that has been assembled from two or more components are known as composite. When they are combined, a material is produced that is specialty designed to carry out a task such as becoming stronger, lighter, and electrical resistant. Additional, it can increase the stiffness and strength. Classical laminate theory, which also takes into account the variable stiffness of each plate in the analysis as well as in plane traction in addition to bending a moment. The general equation for equilibrium and displacement compatibility of plate must be solved in order to determine direction and moment at a specific moment.
Hello, my name is Shankar. My metric number is CF220167, and now I'm going to explain about justifications. So, yield strength versus ultimate strength. As our lecture instructed us to perform a project based on stress and strain in particular material but different material from other groups. Our group chose aluminum foil as our material. The yield strength and ultimate strength are two crucial elements when thinking about mechanical qualities. The yield strength specifies the highest stress required to elastically deform the part. On the other hand, a material ultimate strength specifies the maximum amount of stress it can endure before fracturing or going plastic or permanent deformation. So the experiment ongoing tensile load applied on aluminium creates an opposite force to pull the aluminum foil. The aluminum foil experiences deformation. Okay, let's talk about the graph as I'm shown in the left. The graph shows us the details of the curve, meaning when the first curve appeared which has no yield strength, then the graph experienced an increase until second curve appeared which was known as ultimate strength. From yield strength, The graph increases because the molecule inside the material is trying to rearrange and deform to a new shape. So the ultimate strength is based on the new deformed shape. Based on the data from three samples, our samples, we had collected the first sample data not same as figure 1. The graph shown in here and the graph shown the previous letter, someone will explain that it's not same. Although different material, the graph curve should be same. The yield strength and the ultimate, then the fracture should be same as shown in this graph. The second and third samples mostly similar to figure 1.1. As a result, our team proved that the data of sample 2 and 3 is liable because the data of sample 2 and 3 has a curve similar like to the graph I'm showing here. So we have proof that the data 2 and 3 is similar to the graph I'm explaining now. Thank you.
So this is the video of the process how we make our sample. So the first process is we made at the library all the team members, and then we're using aluminum foil and uhu glue to make it the sample. Next, we go to the light lab structure to make this testing of ultimate strength. So this is the process how we gain the data and get the graph.
Hello everyone, I'm going to talk about the strength analysis calculation method of fabrication. First, which is modulus values, which we get from Young modulus formula, and second will be the ultimate strength. As for the modulus value, we can obtain it from the graph. Therefore, the Young modulus for our sample testing is 901.58 MPa. The value of Young modulus aluminum can be differ because we might do errors during our sample production. We apply the Young modulus formula, which is stress over strain. Therefore, we can compare our material strength with other materials as relatively this aluminum sample has high Young modulus value. Since our graph shows a different trend of uh, result, therefore the yield strength and ultimate strength is taken from the same value. So therefore the average plate ultimate strength for this aluminum sample is 10.83 kN per mm square. Since the control variable in the sample production involves manual work by humans, which is us, therefore there are high possibilities of errors in production process such as cutting, application of glue, and the sample of dimension. As for the calculation, we take the average maximum point load from the testing, which is 0.4323 kilonewton. As for the stress, the formula is P max over area. So our load is 0.4323 over the area is 20 times 2. Therefore, we get 10.81 Newton per mm square. As for the strain, which is changes in length over original length, and we get 0.011.99 mm. Thank you.
Okay, next we will count the Young modulus using this formula that is stress over strain. So the stress we got is 10.18 Newton per millimeter square, and divided by the strain is 0.01199. So we got 901.58 megapascal. So this is our Young modulus for aluminum foil. Okay, next we move to the discussion. From this project, we can see that every group have done their own testing at a lab with using a different materials, and these are the materials that every group use. Okay, for the group one, they use drawing paper, and group two use aluminum sheet. Group three use box. Group four using craft paper. Group five using a fiberglass. Group 6 using paper, group 7 using polyester, group 8 using foam board, group 9 which is our group using aluminum foil, and group 10 using acrylic board. Okay, so for this project we need to testing all the materials using the universal tensile testing machine, which is at material lab. So we need to go there uh, and test each of our sample. So the testing of the sample will show that the form of graph, which is the over strain. From the graph, we can determine the modulus of elasticity, yield stress, and the ultimate tensile stress. Okay, from our class, there are 10 groups, and each group use their own materials and test. So our group will get the modulus of electricity, which is our group using aluminum foil, and the modulus of electricity is 901.95 megapascal. This is for our group modulus electricity. So for the strongest modulus of electricity is from group 5. They use fiberglass, which is volume the value is 7,669.67 megapascal, and the lowest value from our class is polyester, which is from group 7, and the modulus of electricity is to 20.78 megapascal. So this is our total of the strength and the lowest modulus of elasticity. Okay, for the conclusion, we learn how to apply the composite material into a different material and how to identify the problem that limited in perform and reability of the composite material and composite part, and propose solution that lead to the innovation in design and the successfully exploitation and commercialization of composite material across the wide spectrum of engineering use. So in every test, conduct has already produced a good result and good for us to continue and good data for us to continue the calculation work and be able to distinguish every member of the group has a young modulus. So that's all from us, group 9. Thank you.